above the trees with the least amount of hardware. I was thinking about all the empty space there is between about 500 feet and 1,000 feet. It's pretty much empty space there. The private planes usually fly 3,000 to 5,000 feet. The commercial planes are up around 25 to 35,000 feet. And there's just a lot of empty space up there between 500 and 1,000 feet high. I started doodling on some paper, and before long I came up with something that I believe is probably the best way to do it. It wound up being this. This is a patent pending device. It's a one-piece construction that takes the place of a tail rotor on a helicopter. With this device, there's a lift rotor up here on top, or inside, below the shroud, but above the vanes, and the lift rotor is maybe an inch or two above the vanes, and it's close fitting to the shroud, so that the shroud winds up giving the lift rotor 20 to 40% more lift than a lift rotor spinning in free air would have. These are they're vanes, but they're airfoil shaped vanes. For instance, up to 75% of the lift of a airliner comes from the top of the wing, and so these are airfoil shaped to where they generate lift laterally, horizontally, if you want to say. Since this would be the way it would take off, it would lift up like that, and the airfoil vanes generate lift using the downdraft from the lift rotor, and it generates lift in an opposite direction to the torque forces. Torque on a lift rotor, if it's spinning this direction, it's going to make the entire craft want to spin in the opposite direction. And this device, this module, stops that. This module is manufactured in torque stability. It remains in torque balance or stability regardless of the load or the power setting. Changing loads, changing power settings, this remains balanced. It doesn't need any adjustment. There's only trim adjustments, but the module itself stays in torque balance. It can be made with a 3D printer. In fact, that's what this one was. It can be used in a toy or a hobby craft type craft, radio controlled, unmanned aerial vehicle. Larger ones, these could be made up 10, 15 feet across in diameter, because of the way it's made. The airfoils connect to the duct, and they connect to this center control mount, which makes it a very stable, stiff construction. And if you could make them from 10 inches like this one up to 10 feet, maybe 12, 15 feet. I've envisioned what I call a body copter. It'd be a personal rotocraft. It would have no exposed rotors. The only rotor, there's only one rotor. It spins in one direction, and it's up here in the shroud. It'd be up above your head. You'd be in the downdraft, which would be about 60 miles per hour, kind of like sticking your hand out the window on the highway. You possibly could have a a cone shaped shield over your head or over your body if you wanted to, but that shouldn't make any difference in the lift. But once you have this in place and you have the rotor, you'd use a motorcycle drivetrain, which electric motorcycle drivetrain. They're making many of the brushless DC motors with plenty of torque and horsepower. The one we've got in mind is 54 horsepower. The size of the shroud would be 85 inches, and the rotor itself would actually be an airplane propeller that Ivoprop makes. Ivo makes a constant cord 84-inch, they call it the air paddle, and we would use a ground adjust constant cord air paddle with 3 blades. That would give us a lifting capacity of 600 to 700 pounds, with the craft itself weighing less than 250 pounds. We also have plans, and in fact we did our first test flight with a what we call the family flyer. It could hold maybe up to 6 people sitting around in back to back with a lift rotor on the bottom with the vanes, the airfoils, and a articulated top rotor, so it would steer like a helicopter. No exposed rotor blades. Manufactured in torque controls. It's a fail-safe type mechanism. It have more lift than a free rotor operating in free air, while at the same time controlling 100% of the torque reaction. In other words, being stable in the air. Might have a 10-foot bottom lift rotor, maybe a 5-foot top steering rotor. But these can be made by 3D printing, in a method I just heard of that's 50 to 100 times faster than the ones they have now. Has a pool of resin, and the machine pulls the resin up out of the pool, and while it's doing that, ultraviolet light is hardening the resin in the various designs, whatever you want it to make. So, and that would be the entire manufacturing process, since this is a one-piece torque control system that remains in torque balance regardless of load or power. Just for instance, you could put floats on it and land on a lake for some fishing or sports activity. But basically, I made it so that it would fly just above the trees or above the 500-foot FAA floor between 500 and 1,000 feet. It would have enough reserve power that if you wanted to, if you needed to land, you would have time to land and have the power to do it. Like I was saying, it could be anything from a 10-inch toy to a 8-foot aerial lift, aerial crane, setting cooling towers and air conditioning. A larger one could fight forest fires. It could be a drone, an unmanned drone, or it could be a a 6-passenger family transportation that you take off and land from your driveway. It could be a military platform that on these remote outposts, it's hauled in on a truck, maybe 10, 12 foot across. It would have sensors that could detect any movement outside of a certain perimeter or outside of a certain radius. If it detected any movement or metal or body heat or whatever kind of sensors you needed, it would rise straight up. It would be armed with weapons that would eliminate the enemy outside of a radius, inside of a perimeter, and lower back down. That would eliminate swarm attacks that have been killing our military people for 100 years, where the enemy swarms in on a remote outpost, kills everybody, and leaves before reinforcements could get there. This would stop that. Easily, quickly, completely. It could be used for reconnaissance. It could be used to drop bombs. It could be used for urban warfare, looking around corners, eliminating the enemy around corners. It could be used for search and rescue, disaster evacuations. There's not just a lot of ranching, farming, herding cattle, just any kind of use you can think of. And this would be, if you compared the cost of highly trained pilots using an airport, having two free rotors like on a helicopter, spinning in free air. There's been a lot of people killed, a lot of damage done by the tail rotors on the helicopters. This has no exposed rotors at all. It's completely safe, and you could learn to use it in just a few minutes by you just have to get used to the controls, because all you would do is raise your RPM, and then as you started coming off the ground, you'd adjust the trim a little bit, point it in the direction you wanted to go, raise up to the height you wanted to be at, and go directly and straight to your destination. Lower the RPMs, land in any 10-foot opening, and you could and then just you would go back the same way, going directly to your destinations, setting down. No traffic, no tires, no wrecks, no anything. You could have collision avoidance on it and GPS and for guidance, and think of all the empty space that is just waiting to be used just above the treetops. That's what you would have with this, and it could be programmed to stay away from cities and nuclear outfits and antennas and anything else you wanted to, that the government might require, or any kind of obstacle avoidance, or Area 51, or whatever you wanted to stay away from. That would all be automatic and in the GPS guidance system. Hope you'll take a look at my website. You can get there doing vertical takeoff and landing.com, all one word, or you can use tsvls.com. That stands for Torque Stabilized Vertical Lifting System. It is patent pending, and it's ready to go to market. I appreciate you listening, and I hope to hear from you soon.